Hey, welcome to the office today. A little change of scenery. So I needed a new computer desk and I wanted something sturdy with a unique design. So I came up with this steel frame wood top desk, and I'm going to show you how I made it, and along the way I'm going to pack in a whole bunch of welding and fabrication tips for you. Let's get started. Okay, so I'm using 1" by 2" square tubing, and it's 16 gauge, which is about a 1/16 of an inch or 1.6 millimeters. And the first thing I need to do is square up the edge on 2 pieces. And I had these pieces cut a little shorter to fit in my pickup truck, but I'm going to cut the first 2 pieces to 24 inches. And in fact, I'll do 4 so I have enough for both sides. And notice I'm marking with a scribe rather than a marker, because that gives me a really fine line that I can follow and line up here on my saw. And then once I come down, I'll get a cut that is just right. So I'll go ahead and cut 4 pieces here to 24 inches for the top and bottom side pieces. And if you notice here, just the way they were marked there with that scribe and cut with that chop saw, they're right on 24 inches. Now there's a little bit of oil on these pieces from manufacturing. I'm going to go ahead and clean that off so that they'll weld a little better and paint a little better. And then I'll start by putting in these strong hand tool stops into my Langmuir fixture table. And I'll just measure over, and I want the top of my desk to be 31 inches, which is a little higher than normal, but usually desks are a little short for me, but you can make it whatever height you want. But I know those top and bottom members need to be parallel, so that's the first thing I want to make sure is locked in place. So I'm going to go ahead and clamp them, get everything really nice and secure here. Now I'm marking just a little reference mark halfway across so that I can make some diagonal pieces here that will sit on the side to form a triangle. And to set my saw, I'm just using this protractor. You could also use a bevel gauge if that's what you have, but I'm just using that to make sure I get my saw set right on the mark that I want. And this will work for most of the angles that I'm cutting. So I'll go ahead and cut my first angle here. And rather than doing a lot of math on the lengths and angles, sometimes it's easier to just fit up and measure as you go by putting the first things right in place. And if you look, I got that cut right on what I had checked before. And then I'll set it in place, and I'm using this machinist square to help me line it up with that top member so that I can get it right in line. And then I'll use the same machinist square on the back side to be able to mark it so I'm not projecting my view down, but rather cutting it. And see, when I cut it this way, I get this piece right here that fits right in place, and I can move it around, and this piece will fit in each of the positions that I want one in, right? Whether it's top to bottom there or on the other side, it just fits really nicely everywhere. So I know that I have this the right length, and I'm going to use this piece as a standard to mark my next 3, and I'll just mark them with the scribe there and cut them, and I'll use that same piece to mark each one so that they don't grow a little bit each time. So I got that in place, and then I cut these upper members there just the same way. Now I'm using this titanium MiG 170 welder from Harbor Freight just to kind of try it out here today. It's not my normal machine, but it actually works really well. I ran a couple of samples on 60 thousandths of an inch material, similar to this thickness, to get it dialed in and make sure I have a setting that'll work not just for one joint but for all the joints, because I want to find some middle ground settings that I can use here to weld this groove joint. So I'm just double checking on these cutoffs of material. It's not a bad idea to just check it out. So I'm running these flat groove welds here on the sides, and I'll check them to see if I got penetration through, because I can look right on the inside here. Not that we need anything too strong here for this desk, it's already overkill, but you can see it's a little hard to see in there, but it did penetrate clear in. Now I'll just make sure that I can run this outside corner there, and I did try that on some samples as well, even with a little bit of a gap. And then I'll try it out on a fillet weld, and that way I can be sure that I'm ready to go. Now I'm tacking these loose members in place. Notice they don't have any clamps on them, so I'll tack them in place first. Now sometimes, depending on what kind of fixturing you have, there's a strategy to the order in which you tack. Usually, if you have one corner that's a little longer than others, because things aren't cut just straight, that's a good way to tack. But here, since it's clamped down, I can tack about any order. Now I'm starting to weld out the joints. And there on that edge, notice that I welded from the inside to the outside, because as far as weld distortion, it will usually pull towards where you end your weld on a flat weld like this, right? So that would tend to open up the joint, and when I weld that inside corner of the fillet there, that will close it back up. Though it's not going to make a difference too much in this case, as you know, I mentioned before. So I'm just grinding these flush because that's the look that I want, and I'll go ahead and flip it over and set it down and just clamp it back into place to keep it from distorting the other direction. You can see it's just fitting right between those stops really nice. Get everything held in place here for the next weld. So on these next welds, I'll go ahead and zoom in and show you a little bit of some of the joints that you'll be dealing with here. So a lot of them have a piece of tubing joining into another one. So if you notice here, that rolled edge that's on the right side of your screen, I'm spending more time there than on the part on the left that's the tubing butting up to it, because that will take more heat in rather than burning through. So I get a pretty good result doing that. I'll show you one more time. So notice here, again, on the right side is that rolled edge, and on the left is the tubing that's butted up against to it. So I spend more time on the thicker part there, and then a little less on the other, and once again get a result that I'm pretty happy with. Right, and so this machine's actually working pretty good. I got this machine to run an aluminum spool gun primarily, but you know, I threw some wire in. I've been trying it out. I'm going to do a review on it here coming up as well. Anyway, notice here the gap is different on these two, so as I go along I'll just need to adapt to that, right? So I'm just visiting that thin piece where it's butted up and living on that rolled edge. And here where there's that gap, I need to bridge it, but I can't spend too much time over there on the part on the right side of your screen without burning through. So you can see it's melting back, but I'm able to sustain it and still get a result that'll work for me here. So I'm pretty happy with that. Now, the next part is capping the corners, right? And I'm going to have to run these corner joints after I tack it in place here, and that's why it was good to get my settings dialed in before so that I could run all of them. Now here I'm not doing a lot of weaving back and forth. I'm running just a stringer straight along and trying to stay centered on that joint the best I can, and it turned out pretty good. Now I'm just doing a quick overview of the whole process so you can see on the other leg the process from start to finish. So I'll get it all welded out, and then I'll go ahead and weld those fillet welds inside there, and we should be pretty well good to go. Notice I'm going back and forth on those end caps to let it cool a little bit in between each of the joints. Now I'm using some runners that run from right to left all the way across underneath the top of the desk rather than just screwing the legs to it, because I want it to be really sturdy, but I don't want a bunch of bracing underneath. So I'm going to use a vertical reference surface here on my fixture table and clamp it in place on both sides. And then I'll also tack it to get everything fixed nice in place before I weld it out. And so you can see I'm starting just by welding the sides, and then I'll go all the way around. You can see all the different types of joints here. This is just great practice to be able to run these different types of joints together. Now I don't want this thing to wobble, and so I'm marking here on the bottom, and I'm going to center punch and drill a hole to put in a threaded insert. And for the threaded insert, I'm not going to use anything special. These are regular inserts you can get for wood furniture from the hardware store. They have little holes for brads to attach them to it, and it looks like this Harbor Freight drill bit has about seen the end of its life, or I need to sharpen it at least, but you know, we'll fight through and get the job done one way or another. Anyway, I'll set it in place here, and whenever you're welding anything with threads, it's a good idea to put a screw in it. And so I'm just throwing a tack weld there, and if you notice, I'll just start welding on the actual tubing, and then as it expands, it'll work its way into the insert. That way I don't burn through that thin material, and I can throw this foot in here and it threads in nice. So I put on some paint. It's an oil rubbed bronze color. You could use any color you want, and then I'll go ahead and start getting this butcher block top ready. Now this is Hevia or rubber wood top, which is you know, it's a really good price for how hard it is. And I'm just rounding the corners here. You can see I'm a little less comfortable maybe with the woodwork than under the welding hood, but I've done a little in the past, and it'll work out okay. But I'll go ahead and finish rounding the corners here. We'll see if we can't speed this along on the video. And then run over it with a sander, a couple of grits there. And then I'm ready to put on this wood stain. And it started to rain a little bit, and look at those spots. This is awful. it started to rain a little. I let it dry for a day, but it's still soaked in more where those spots were. So I flipped it over and sanded it down, and the other side came out much better. So, you know, lesson learned there for me about not being out when it starts to sprinkle. But after I got that stain on there, I just coated it with a little bit of polyurethane to protect it and give me a nice finish. And to attach it, I'll go ahead and just drill some holes here and put them in with some simple screws. And I'm going to countersink these holes just a little bit. It's mostly just a burring, and a countersink is a really handy tool to have for that. But I'm just going around here and installing these screws all the way around, and that's pretty well it. And here's this desk. I'm really happy with how it turned out, and I think it'll be something good that'll last for years. Hey, well, thanks for joining me today. If you liked this video, please let me know by hitting that thumbs up below, and if you want me to send more videos your way, go ahead and click that subscribe button. We'll see you next time.